So simple. Take an example that I am having a 50. This is a case how you are trying to use the one CT to other CTs. I mean, suppose you are having a spare CT in the substation, and if you want to use that for the other application, can you use or not? So how can you know? You have to check the performance of the CT, right? That is this. Suppose I am having 50 by 5 ratio CT. Then the excitation curve is this. The excitation curve of the CT is this provided by the manufacturer, knee point voltage 1 as like PS class CT. And the relay connected to CT should operate for 60 amps of symmetrical primary current. Means if a 60 amps is flowing on the CT, it should operate. That is my condition. And the CT internal resistance is this, lead resistance is this, and relay button is this. He already given everything. It's a kind of a problem. Now I am calculating that what is the actual primary current needed to trip the relay. Okay. Now let's see. Number of turns 10. Relay operate for 60 bar 10 at 6 amps at CD secondary. If 6 amps at the secondary is flowing on the secondary side of the CT, then the relay will operate. Now, what is the voltage then at secondary side of the CT? We are calculating the knee point voltage for secondary side of CT into the resistance of all this. So it's like 10.7. So look at this excitation graph. If you see 10.7 amps of the secondary excitation voltage is approximately here 5 amps. 5 amps. So the total primary current required is 60 amps plus 10 into 5 amps, nearly 110 amps. It seems that the relay will operate if primary current is 110 amps instead of desired 60 amps. If you use this CT, this CT will not operate at 60 amps, will operate at 110 amps, but you require to operate at 60 amps. So what you have to do? You have to go for the next size CT of 100.5, which will operate at 64.4 amps instead of this. And if you go for 600 bar 5 amp CT, it is having it will give if you are going with a 100 where it is 100 is to 5 amp CT, then it will operate at 64.4 amps. If you are going beyond this, like 200 is to 5 amps, it will operate at 60 amps or maybe less than that. So this is how you are checking the performance CT, means where the CT is operating. If you use this CT and if you place in that in this application, suppose if you use 50.5 amp CT, the CT will not operate at 60 amps. As your 60 amps is the fault current, it will not operate. It will operate at 110 amps. So you have to connect it to the 110 amps here, 100 amps. So sorry, 100 is to 5 ratio. That is the performance of the CT using excitation method, excitation curve method. And this excitation curve can also be used to a CT if a CT is adequate for the particular relay accuracy level from the excitation curve. Like suppose I am considering 600 is to 5 C100 CT, which is some class of CTs which is used in abroad projects. Assume the total button of the CT winding resistance is 0.5 amps. To check whether the relay is adequate, first to calculate the secondary voltage at 20 times of the rated secondary current, which is 50 volts. From the excitation curve here, find that 50 volts, find the excitation voltage correspond to the 10 amps of the excitation current.